Okay, so the next presentation will be by, I hope I pronounce it right, Marcin Dyderski, and he will present something on the spread of invasive tree species, and especially how we can use the assessment for natural regeneration also in risk assessment. So please, floor is
Thank you, Anya.
yours.
Hello, everyone. I would like to say something about natural regeneration assessments. Can you see my screen?
Yes, all here.
Great. This is based mainly on the results of my PhD project when we focus on natural regeneration of alien species. We focused on this because natural regeneration is a crucial phase of a forest development, providing us valuable insights into a forest future. We focused on the seedlings and saplings of three alien tree species: Prunus serotina, black cherry, Quercus rubra, northern red oak, and Robinia pseudoacacia, black locust. All of the results which I would like to show you were collected in the Wielkopolski National Park in the Western Poland, the national park with the record number of alien woody species in Poland, over 100 alien taxa here. In this national park, we established the set of 21 blocks. In each block, we had 18 study plots located in the pairs. The one pair in the middle of the alien tree stand, one on the edge, and one on the 30 meters away from the edge. And these 4 pairs were replicated in the north, south, east, and west, giving us the gradient of the distance from the propagule source and the diversity of different forest types. In total, we had 378 100 square meters study plots. With these plots represented various types of the forest and the whole gradient of the soil fertility and light availability. These gradients were reflected in the vegetation, which grouped among 2 main axes of the vegetation variability. And the main axis of the variability can be explained by increased light availability, higher litter mass, which is the approximation of the matter turning time in the forest ecosystems, and acidity. So the gradient comes from the Scots pine stands on the poor soils via acidophilus oak forest, oak pine forest, beech forests, to the Robinia forest and oak hornbeam forests with the highest soil fertility and lowest light availability there. We assessed the biomass of the seedlings and saplings, because the biomass is the best metric of species quantity in the ecosystems. We used own developed allometric models to assess the biomass within each plot. And then we used machine learning techniques to assess which variable is the most important for natural regeneration. We assessed the biomass of seedlings and saplings separately and together for each of 3 studied species. The variable importance is the percent how much the model quality will decrease, or in other words, how much the model quality, the model bias expressed by the root mean squared error will increase when we shuffle the variable randomly. So we found the higher percent is the more important variable. We found that for all of these biomasses, the most important factor was propagule source presence or propagule source basal area. This means that the natural regeneration of the studied alien tree species is limited by the availability of paternal trees. Also, we found high importance of litter mass, litter pH, light availability, and other storage characteristics, but the presence of the propagule source was the most important. We also prepared the response curves to see how changing only one parameter will affect the biomass. So we can see that with increasing basal area of parental trees, biomass of all species, all life stages will increase. With the increasing light availability in the forest floor, the black cherry biomass and red oak biomass of both seedlings, saplings, and total regeneration will increase. However, we found the highest biomass of Robinia regeneration in the plots with the lowest light availability. This is connected with the fact that most of Robinia regeneration we found was of the vegetative origin. So these plants were sprouts which were supplied in the carbohydrates by the parental trees. We also find that in the most acid litter, Robinia had the lowest biomass, and in the least acid, the highest, while Prunus serotina had a reverse trend. Also, we found similar with the litter mass. This allowed us to conclude that natural regeneration of Robinia have the highest soil fertility requirements, while natural regeneration of Prunus serotina has the lowest, sorry. While Prunus serotina requires the most of light and is the most sensitive to competition, while the least is the Robinia pseudoacacia, also due to the supply by the parental trees. And among these species, Quercus rubra is the most dependent on the propagule proximity. We also studied intraspecific and interspecific variability of functional traits of the studied species and for native species as a comparison. We assessed over 1,000 of seedlings and saplings of 7 species. We divided their biomass into leaves, roots, and stem. And we calculated also the specific leaf area, which is the ratio of leaf area to leaf mass, and inform us of the response of plants to the shading and the efficiency of light capturing in the forest floor. We found that Prunus serotina and Robinia had higher allocation into leaves than native species and higher specific leaf area than native species, while red oak had higher total biomass and higher biomass allocation to the root than native species. We also find that all these traits differed across the gradients of the light availability and litter acidity. However, the differences within the species were much lower than differences in between species. So the strategies of the species were conserved across the different light and fertility conditions. We also assessed the survival of the species studied. We labeled 11,000 of seedlings, up to 30 per study plot in 3 different growing seasons, and we observed their fate after the 1 year. We found that the mean survival of the black cherry was about 4%, of red oak 12.5%, and of Robinia of 0.1%. And we also provide the models of the survival. We found that seedling survival of Prunus serotina decreases with light availability, decreases with intraspecific competition expressed by density of black cherry in the regeneration layer, and with the basal area of parental trees. We also found low survival in the stands with Prunus serotina. For red oak, we found that its survival is higher in stands with higher light availability and with higher intraspecific density, but up to the density of 100 individuals per hectare, per plot, and decreases with the increasing basal area of red oak and is the lowest in the stands dominated by red oak. This leads us to the conclusion that higher parental trees abundance increases the regeneration biomass because supplies more seeds and more seedlings. However, it decreases its survival, shaping the dynamic equilibrium between recruitment and survival of the regeneration. And these relations are modified by light availability and soil fertility. We also use the same data to look on the other side, on the impact of alien tree species on native tree species. We counted all trees and shrubs within all of the plots. We found in total 53 taxa. Looking on the diversity indices, we cannot see big differences between stands with alien or native species domination. But looking on the particular species regeneration density, we can see that, for example, for maples, we found in oak hornbeam forest higher regeneration than in stands with the similar trophy, but dominated by robinia. Also, we found that ash and lime was negatively affected by robinia. We found that in the stands with Prunus serotina, its regeneration is the regeneration of Pinus sylvestris is lower than in stands of Pinus sylvestris without. We also found some examples of positive impacts, but the most negative impact is on Quercus petra regeneration, which was the highest in the conspecific stands, and in Quercus rubra stand there was almost no regeneration of this species. Summing up my presentation, we found that propagule pressure is a crucial factor determining spread of invasive trees and shrubs. Studied invasive species benefit from functional difference from the native competitors, and this difference is conserved across the environmental gradients. Seedling survival is low, from 0.1 to 12.5%, but sufficient for population development. And alien species study decreases abundance of particular native tree species natural regeneration. Thank you for your attention.
Thank you very much.
Thank you very much. This was really interesting, and it shows clearly well how the assessment of natural narration can feed into management proposals also, how important these results can be.